Hello everyone, welcome to the second episode of this multi-part video series on NSX Advanced Load Balancer, also known as Azure Load Balancer. My name is Satya Shrestha, a senior staff multi-cloud solutions architect here at VMware, and together with me, I have Kumar Mittal, who is NSX Advanced Load Balancer expert at VMware. So today in this video, we'll be covering how to deploy VMware NSX Advanced Load Balancer in Azure VMware Solution AVS. Okay, let's get started then.
Cool. Satya, this is our second video for this series. So I would throw it out to you. What were the key takeaways for you from the last session?
Yes, the first part of this video, you covered it really well around what Azure can do in multi-cloud application delivery space, right? So as far as I understood in our first video, Azure is really great in terms of multi-cloud application delivery, as it can provide a central orchestration where it can actually centrally manage all the deployed service engines with controllers. And then those service engines could be either on bare metal instances or even in multiple cloud environments, including private cloud and public cloud, right? And also including our VMware cloud. It can actually manage all the service engines centrally with its central orchestration capability. And all this environment where these service engines and controllers are deployed, it can be actually run in active deployment. What that means is we don't have any overhead of active passive kind of environment. So both service engines running on any environment can be operated in active environment with full resource utilization. And the other thing is about elastic application service fabric, where the app could be elastically or dynamically scaled in or scaled out, which is another great flexibility and awesome app delivery method using Azure Load Balancer. You also actually demoed us the analytics feature, which is awesome, right? The monitoring and analytical feature of Azure. The day-to operations and visibility is really easy with Azure. And we also spoke about the software-defined network, SDN capability, and Azure being the software-defined load balancer, it can actually do a lot of things automatically. The example I gave you earlier around scaling in and scaling out, all of that can be automated, right? And that's another great feature that only load balancer like Azure can provide. And we also discussed about multi-tenancy and how Azure can play a great role in a multi-tenanted environment. And the load balancers can be actually deployed just per tenant, segregating the tenancy, or it could even be deployed per app.
Oh, perfect.
How is my summary? What do you think?
And I would say, you have been able to summarize nearly all the feature sets of Azure just in one session. I'll call you an NSX ALB expert now.
Kudos to you, man. It was all of you who actually showed us all the capabilities. Yeah, so you have been successful, that means.
Pleasure is mine. But this has been about Azure Load Balancer, but the series we are doing is basically how Azure can actually automate the application delivery in AVS environment. So I would like to know from you more about AVS environment, what feature set AVS provides.
Absolutely.
And how it is different from the Azure native environment.
Yeah, absolutely. Let's talk about Azure VMware Solution. Though, like Kunal said, we will be doing the same thing for other multi-cloud environments, including VMware Cloud, AWS, Google Cloud VMware Engine. But in this second episode, we'll be covering mainly around Azure VMware Solution. Okay, let's talk about AVS, Azure VMware Solution. Azure VMware Solution is Microsoft's first-party solution. What that means is Microsoft is responsible for its management, its deployment, its lifecycle management, its support, right? So it is Microsoft's first-party solution, which can be deployed directly from Azure portal. Azure VMware Solution is a software-defined data center deployed in Azure VMware Private Cloud, where you can deploy the SCDC as you would in your on-prem. And that SCDC, the building block is VMware Cloud Foundation, VCF, which is composed of vSphere, vSAN, and NSX, right? And then for management, we have vCenter as usual. With Azure VMware Solution, it can be tightly integrated with your on-prem environment, as well as your Azure services like Azure AD, Azure Monitor, Azure Security, Azure SQL Server, and so many hundreds of services that Azure provides, right? So that's why the value proposition of Azure VMware Solution is really great, that you get a highly performant enterprise-grade software-defined data center sitting in your Azure environment that can consume resources in on-prem, as well as on the native public cloud as well in Azure. And the SDC that is running in there is basically a bare metal server, which is a highly performant hardware that is actually provided by Microsoft Azure.
That's interesting. So can I say basically, as a long time into networking industry, and I have been playing with NSX into the data center on-prem environments, yes. I would get the same, my experience of designing and deploying VMware software-defined networking using NSXT on-prem in Azure hyperscale environment as well. And basically, I can take same capability and my knowledge of NSXT and VMware solutions and go drive and deliver a business application in Azure. So what I get underlying is the scalability and elasticity of hyperscale environment, get to keep my knowledge, but then also deliver the related infrastructure applications, like you said, AD, etc., using Microsoft stack in Azure.
Absolutely. You got it really correctly. So using your skills that you already have on all the VMware stack, you bring it as is. You don't need to relearn the skills that you already have. That's another very big value prop of AVS, Azure VMware Solution.
No, beautiful. No, I love it, man. So that's from the Azure VMware Solution, but at the end, enterprise are actually looking for a scalable and automated way of delivering business-ready application.
Yes.
And that's where load balancer play a very critical role, be it on-prem or in Azure VMware Solution. And you have been doing those kind of deployments from quite a long time. So I just want to understand what has been your experience when it comes to application delivery in Azure VMware Solution. What are the challenges that customers face when they are delivering applications in AVS environment?
That's a great point, Kumar. So when we are using Azure VMware Solution and when we are delivering application using its native, for example, the native load balancers, right? Yes, they have a really good native load balancer there, but the native load balancers that comes on any public cloud, not just Azure, but other cloud as well, right? They are very basic in nature. The capabilities that enterprise load balancer provides, those capabilities may be lacking on those native load balancers. So when we talk about enterprise grade load balancer, what I see missing in this native public load balancer is they may not be great with scalability, right? And then also the capacity management, when we are talking about legacy kind of architecture, that may not match properly with the native cloud load balancing. The other thing is operational visibility and analytics. This load balancer, they don't have inbuilt feature that day-to-day operations people will like. The thing that we discussed last time, the analytics, they're really basic features. If you wanted that kind of visibility, of course, you can use other native public services. Again, it will cost you money, but the load balance itself, they're not able to do it themselves, right? And then the other operational challenges regarding support, when you have enterprise grade load balancer, you are using it in Azure solution, then you may have to run through multiple hoops of support, right? So probably Azure services are supported by Azure, Microsoft Azure people. Then if you are using a third-party load balancer, then you have to go through the other support, right? So there is a limited native load balancer support, and especially the enterprise features that I spoke about earlier, they are missing in the public load balancers. So those are the limitations I see and the challenges I see when we are delivering applications in public cloud environments.
I guess these are very common challenges that even I hear when I'm talking to my customers in application delivery space, even on-prem. And I always thought that in a hyperscale environment, those problems usually wouldn't exist, but I'm really amazed to hear that these are similar challenges that customers are facing in hyperscale environment. And the reason being, because they are taking their legacy appliances up into the public cloud. So basically the same technical debt that has been deployed on-prem is replicated onto the public cloud as well. And that's where the overall automated and orchestration story fails.
Yes. The other thing is going back to the support. If let's say the application delivery is being done in multi-cloud environment, you just double that, right? Whatever challenge we saw in one cloud, you just double that with multifold. So if you have application, for example, being deployed in Azure and then one in AWS environment, then again, there is a siloed environment, there is siloed support. You have to reach out to AWS separately, Azure separately. And if you have third-party load balancers getting deployed there, then you have to even contact them as well. So the support becomes really challenging.
Oh yeah, that's true. And don't forget about the multitude and multiplied effect of the different team of experts that are required for multi-cloud environment if you're using their native tools. Because Azure has their own sets of native tools, which does not scale out of Azure environment. And if you are looking to have the workloads deployed in Azure and AWS, then you'll have to go and maintain separate set of skill sets who are trained in Azure and then in AWS. So basically, there is a lack of democracy of application delivery and application delivery breaks.
So Kumar, we talked about the challenges that we see in public cloud environment when it comes to multi-cloud app delivery. Now, can you describe to me how the high-level architecture of NSX Load Balancer looks when we integrate it with Azure VMware Solution?
First thing, RV being a full-featured load balancing solution, which helps in providing application resiliency. If you have a multi-geo application presence and it has GSLB, you can apply security control through WAF and rich analytics that is available. So that's what RV brings to AVS when applications are deployed in AVS environment. And then a couple of use cases that can kind of be easily run are like, you can have a standalone single SDDC environment, do disaster recovery through GSLB and DC expansion, or even burst capacity through auto scaling. It kind of coherently integrates with the AVS, which is also elastic underneath. So you have your infrastructure elasticity. Now you can do application elasticity, but at the same time, you can have application deployed in an automated fashion on an application delivery platform. And as a business, the applications would always be available for your customers, be it in a single data center or in multi-data center environment.
Now, so this is really high level, right? How about we double click on the AVI components, let's say 100-feet view of actually how AVI looks like? in AVS.
So you're getting close to my heart and asking that particular question. RV is a distributed architecture based on software-defined principles. The RV controller sits in the SDDC, and it actually, using the API integration, would actually go and integrate into NSX Manager, and it would also make that API integration into vCenter, which is your management zone. And then it would actually go and start deploying your service engines and manage the lifecycle of the service engine, and also do elastic scaling of the service engine. It automates the connection of service engines into the logical network, deploy virtual services by allocating that IP address and through its IPAM and allocating it a name. And it all does all that in a very elastic and an automated fashion. And let me take you into a bit of detailed steps into how the deployment is done on a day 0, day 1, and then ongoing further management. And then we'll break down all these steps into each of the function, where I'll be able to give you much more detailed view as what RV in the is as an administrator that you are doing, performing the function on the RV, but what the background RV also on the controller is also doing as part of its API automation suite.
Absolutely. So in this diagram, what essentially you're saying is everything is done through API. It integrates really tightly with NSX Manager as well as vCenter. And then all the things that we need to do in NSX, for instance, or vCenter, it just calls the APIs and it just does the thing underneath, right? We don't need to even worry to touching like manually doing things on NSX or vCenter, right? Everything's done through API and just the user clicks.
Yeah, correct. Because that's where the whole RV architecture is based on REST API, and that's where we have taken those REST APIs to provide that integration into different environments. And this is what API-driven automation we talk about.
Excellent. Okay, let's go through the deployment steps then.
As a deployment, there are two components, controller and service engine. So basically, controller is deployed manually in any environment. For NSX cloud integration, which is especially for AVS environment, which we will be using, because controller goes and connects, underlines into NSX, your LCM. That's where controller node version, minimum 20.1.4 is supported. That's where the controller node can be deployed anywhere. When I say anywhere, the recommendation is where your target state, if AVS is the environment where maximum workloads going to reside, that's when your controller in AVS. And in a production environment, the 3-node cluster of controller is what is recommended for high availability and resilience.
Right.
Whereas the service engines are automatically deployed by the controller.
Sounds great. Okay, so yeah, let's move on to the integration, how it is done with AVS.
Correct. So this is how your day 0 integration looks like. So once you have installed the controller in AVS, SDDC, that's where now administrator would log in into the controller and would actually go and integrate your controller into the NSX manager. So at the back end, what RV does when its API actually go and integrate into NSX manager, it fetches the NSX transport zones, your transport nodes, logical segment, tier 1 gateways, NSX groups, etc., that are all configured through NSX manager. It would go and fetch that.
Right.
Then an additional step is you would actually also go and integrate it into your vCenter.
Yes.
And the point number 3 and 4 that is being listed over here. In the backend, what it is doing is that it is actually fetching through the vCenter. It fetches the ESXi host corresponding to those transport nodes and port groups.
Right.
Though at the moment only one vCenter server is allowed per cloud.
One vCenter.
Correct.
Yeah.
And also it would actually go and upload the SC OVF and VMDK image into the content library of the vCenter.
Oh, okay. So it touches content library as well, just uploading the service engine so it can be deployed in the future, right?
Yes, correct. Every controller version would and the controller would be responsible for the SE image, creation of that image. Right. And that's where it would create the image for the service engine corresponding to that particular environment, and supported image would be uploaded. So in this case, it is an OVF and a VMDK file that would get uploaded into the content library of the vCenter.
Yeah, that makes sense. Yeah. And
then, so from there on, once your day 0 function are done, you are pretty much set actually to deploy your first application. And that's where the LB admin or the application admin would go and create a virtual service to front end an application. And RV controller would go and automate the following steps. What it will do is it will create an SCVM, and it would actually go and check that there are enough resources that are already available on the ESXi host. And it would trigger the VM creation using the OVF that was uploaded in the content library in the previous.
Again, everything through API itself, right?
Yes.
Got it.
The interesting thing is the anti-affinity rules are inbuilt. So when I say anti-affinity, your 2 SC images that or the VMs that are spent would by default be spent on 2 separate hosts.
Nice.
High
availability already. Okay, got it.
Yeah. Also, it would go and connect it to the correct network. So the data interfaces would be on the service engine, would be connected into the right overlay or the VLANs. Then it will go and configure static route for the web on the NSX distributed routing. And it will also go and configure your NS groups with SE as members, and also update your TCP UDP services in the LB pool.
Nice. And it does all of that itself automatically.
Yes, correct.
No, nice. Very nice.
So when I say that, your NS groups and services on the on your distributed firewall policies would be automatically pushed by the controller, and they will be configured. So in the nutshell, what I'm saying is your SEs are configured, they are plugged into the right VLAN or the overlay segment. Your virtual service is configured. Your distributed firewall on the NSX would be configured, and your routing would also be configured, be it static routing or you're doing BGP based on NSX Tier 1.
Sounds really good, man. Everything is tightly coupled here. Really nice.
Correct. So basically, if I have to summarize everything from a day 0, day 1, and day n function, on day 0, admin is actually going and deploying the controller, doing an API integration into NSXT, into your vCenter, and make sure user roles when you're integrating into the NSX manager, it has the admin user right. Similarly, vCenter user has the cloud admin user right. Once that is done, on day 1, you are actually ready. Your DevOps engineer is actually ready to go and deploy the virtual service. And RV controller would deploy your service engine and your virtual service for that particular application. And then your day end task would be, you can actually go and deploy multiple applications and get onto your operational and management task. And if you see the difference from the automation it brings, as compared to your traditional load balancer, where majority of the tasks are manual driven.
Yes.
Where for every task, you actually have to go and raise a ticket, be it configuring, deploying your first application. You actually have to find the underlying resources, then raise a change to actually go and configure your LB, your standby load balancer, then raise a change again to configure routing, and then open firewall policies, which is kind of a week-long process, is now handled in an automated fashion by RV controller, and your services are available within a matter of minutes.
Yep. That cuts down deployment of load balancers and all related components, right? That's really great. Yeah.
If I went into the environment, basically, there are some functions which has to be manually performed even before you actually go and start deploying RV. And this is for any particular kind of load balancer when you are actually setting up your NSXT environment. So basically, what NSXT admin is doing is it is creating its tier 1. And then a local segment for RV management. And then it will go and configure, do the redistribution of the route so that when the service engine is being deployed on the local segment, it can actually go and communicate with the RV controller.
Right. So the picture that we're seeing here, this architecture diagram, is this the best practice that we should be following when deploying RV components?
You can definitely take it as a best practice, but then it is not the only way. I mean, usually you would have a management tier where all your management functions would be placed. This is where in the management tier, once your controller is being deployed, you would actually go and deploy service engine. Now, service engine would have 2 interfaces by default. One is the interface which would actually go and connect into the SE management segment, as highlighted over here. And that is the interface that service engine would take to go and register and communicate into the controller. As a controller is managing the complete lifecycle of the service engine, and it uses port 22, basically SSH, to manage the service engine over there. And then is the second interface, which is your data interface or the VIP segment, but would actually go and connect into your VIP segment if you're using a single arm mode service engine. So it will go and connect into the VIP segment, and this is where the interface would have its own IP address. And then once the VIP is deployed, and they will have their own IP addresses. This is where your service engine would sit. And once the virtual service is being created, the controller would go and configure a static route onto your tier 1. And then from tier 1, that static route gets redistributed into a tier 0 via BGP or via static routes, and then it is available for the clients to access the application.
Right. Okay. So the basic preliminary task before even we deploy other components of Ivy is to have those tier 0, tier 1 in place, and also the segments in place, and proper IP range planning, all of that, right? So once that is in place, then we can deploy controller, and then controller can take care of everything else.
Yes, correct. I mean, it is like any other deployment you're doing is where that you're starting with the right plan of action so that you can go into a deployment mode from there on.
Okay, that sounds good.
Yeah, I guess getting into our RV AVS demo lab, or the environment where we will be looking to play and deploy our RV controllers, I guess majority of it you're already onto and you're doing it. So how have you planned the environment?
Yeah. So for next video, I think we're going to go through all the hands-on and demo part, but let me describe how we have configured a demo lab for IV controller and service in the deployment, right? So as you can see in this diagram, in AVS, we have tier 0 and tier 1 deployed for us. You can see the names in there for tier 1, TNT84-T1, that's the tier 1 that we will be using. And in that tier 1, that actually has 3 logical segments, as you can see here. Let's start with the top one, where you can see a controller segment. There is a controller segment called MCA AVI controller segment, that's Satya LS, and its IP range is 10.121.11.1/24, right? That's the IP range that we're going to use for controller. And the IV controller will have an IP address of 10.121.11.1.181. Now, we will deploy that IV controller. Once that is deployed, then we have already created the VIP data segment and web segment already. So we can actually have right segments where we'll be deploying service engines. Service engines will be deployed on VIP/data segment. There is a data segment or VIP segment called MCA VIP data segment with the IP range 10.1.1.134.1/24. That's where the service engines will sit. And on the web segment, that's where we will put our web servers or web machines, right? And the segment for that one is MCA API web segment with IP address range of 10.121.133.1/24. So I have already set up these logical segments. We'll go through each of these, and also we'll talk about how we deploy AVI controller as well as how we deploy service engines in our next videos. But to just sum up how our demo lab looks like, this is how it looks like. Now, Kunal, you mentioned about NSXT control, etc. Can you describe that, how AVI controller is communicating with NSXT here?
Yeah, sure. So as you have planned, Satya, AVI controller sitting on the MCA AVI controller segment. The service engines will be sitting on MCA AVI VIP data segment. Now, because they are connected to the same tier 1, we can have a single interface service engine where it can use the same management interface, which is allocated to the service engine in the VIP data segment to actually communicate back into the AVI controller, because we are on same tier 1.
Yes,
and we'll also use the same segment for VIP placement. So basically, our VIP will be getting placed onto the management segment itself. And the communication between the backend pool, which is our web segment, and the service engine would take through tier 1, which is TAT84 tier 1. So what would happen is once the AVI controller goes and deploys service engine and the virtual service on top of it, the IP address that is allocated to the virtual service, the static route for it would actually be created on tier 1.
Got it.
For that virtual service. It's a static IP address, so we'll redistribute the static IP address from the VIP subnet, and that get redistributed onto tier 0, and tier 0 will actually go and redistribute it into its BGP routing.
Okay. So that's how the routing actually works on this instance. Okay, so we will just describe about the demo lab now, but in our next video, which is our third in this episode, we'll be absolutely showing the same deployment and how every component is deployed and how it is configured, right?
Oh, perfect. So I'll just summarize in terms of the overall virtual service and pool creation from day 1. So the manual part is deploy your controller, do the API integration into the NSXT, and vCenter in your AVS environment. That's the day 0 function. Then the day 1 function basically is you go and configure your virtual service. And whereas you create your VS, you create your static VIP and IPAM, configure service ports, configure pool members, etc. And then the API-driven automation part is the VIP placement, where service engines gets created onto the transport zones, and AVI controller auto detects your logical segments, where the VIP subnet and SE VNIC will be placed, which is our data segment in this scenario. And then the placement network must be selected on the VS for the VIP, which is not part of the subnet on any logical segment.
Okay.
So this is in a nutshell the day 1 function. So if I have to go and summarize the challenges that you posted right in the beginning, the challenges that are being faced for application delivery in the public cloud and hyperscale environments and AVS, I would say we would be able to mitigate all those challenges of scalability and performance. Why? Because of the software-defined architecture of AVI, where underlying service engines can scale elastically with auto rebalancing and dynamic auto scaling across the data plane. It can handle the load as it grows.
Yes.
And then with the rich operations and visibility and analytics, which is provided through the controller, as we will be doing once we configure our first application and we are accessing that particular application in the demo environment, I will be able to show how you are able to look at each transaction and the client experience that they get in accessing the application through AVI Load Balancer. And then definitely operational support is another part where you now get a single vendor support, be it AVS, where you have underlying VMware environment running on Azure, and then your application delivery also done through AVI Load Balancer.
Yeah, absolutely. And even when we start spinning up VMware Cloud AWS and Google Cloud VMware Engine, and when we place the services, etc., on those clouds, so it's essentially the same party, right? So we will be responsible for all of that. So any support issues, you go directly to us, and it doesn't matter what environment it is, the multi-cloud support is done by VMware.
Oh, perfect. Thank you. And stay tuned for the next one, where we would actually be diving into the demo and the lab environment and getting our hands dirty by deploying controller applications into the environment.
Absolutely. So the next one is going to be full hands-on demo, and also we'll be talking about all the service components, controllers, service engines, etc. And we'll be showing you how exactly it's deployed, how exactly it is configured, and how everything looks like, right? Whatever we talked about today, we'll be deploying and configuring in the real environment. So with that, thank you, Kumar, for your time today. It's been great hosting this second session together with you. And thank you, everyone, for your time today. Hope you find this video useful. And we look forward to seeing you on the third episode of this multi-cloud application delivery with NSX Advanced Load Balancer series, where we'll be demoing all the things we talked about today. Have a good one, everyone, and we'll see you on the third video. Bye for now.
Thank you, and stay tuned.